I'm a creative determined to survive the AI revolution. I'm learning about AI and you can too. In this video, we are going to discuss software, but before we jump into installations, let's clarify an important distinction between the two types of installation methods you will encounter. The first is normal installation. This is the familiar process where you double-click a file, follow the on-screen prompts, and the software installs automatically. The second is the manual setup in virtual environments, and this is a bit more advanced and involves isolating specific AI tools in their own virtual environment. For this video, we are focusing on normal installations. Virtual environments will be covered in the next tutorial. Additionally, some of you eager beavers might wish to skip steps, but if you skip steps 5 through 8 and leap directly to step 9, you might run into some issues. So do stick with the order in this video. So first things first, we need to ensure your Nvidia GPU is ready to handle AI workloads by installing or updating your Nvidia drivers. Note, if you already have an Nvidia driver installed, you do not need to uninstall it. You can simply download the latest version and it will install over your current driver version. You will want to open your Nvidia control panel from the Start menu. This shows your GPU information and driver version. For example, my system shows driver version 560.94 installed. Make note of your driver version because it needs to be compatible with CUDA, which we will install later. And remember, CUDA stands for Compute Unified Device Architecture, and it is the software framework Nvidia GPUs use for AI-related mathematical calculations. Next, you want to verify that your GPU is visible in Device Manager. You can search for Device Manager in the Start menu and open it. Expand Display Adapters to check if your GPU is listed. If your GPU is not listed, or if you need to update your drivers or you don't have a driver installed, you will want to visit Nvidia's drivers page, and all links will be in the description. You can enter your GPU model and operating system details. You might like to choose the Studio driver as it is optimized for content creation and AI tasks. Unless you're also playing games on this computer, in which case you would want the Game Ready driver. Then you go ahead and download and install the driver. And don't forget to restart your computer after your driver is installed. The second step is to install Git. Git is essential for downloading and managing software from GitHub repositories, which is a big part of the setup process. So here's how to install it. You're going to visit the Git homepage. Again, links are in the description, and download the latest version. Most of you will want the 64-bit version, but if you are unsure, you can go to search bar near your Start menu and type System Information. Look for system type to see if your computer is 64-bit or 32-bit. Once Git has downloaded, you can run the installer. And during installation, you can stick to the default options. Since I already have Git installed on my computer, I will not run through this entire process, but if you're installing for the first time, simply follow the prompts to complete this setup. Step 3 is to install 7-zip. 7-zip is a free tool used to extract large files such as ffmpeg, which we will install later. You will want to go to 7-zip. Again, links are in the description, and download the 64-bit version. Next, you run the installer, and you stick to the default installation options. Step 4 is to install Miniconda. We'll use Miniconda to run Python code and create virtual environments. So you're going to download Miniconda from its website. You will follow the prompts during installation. And when asked whether to make it the default Python, you can select yes. If prompted about adding Miniconda to your path environment variables, you can leave it unchecked for now because we will set this up later. Now, step 5 is pretty intense. It refers to researching your AI tools. Before installing CUDA, we should research which AI tools you want to use. This step helps you pick which CUDA version is most compatible with your AI software. If you're watching this video around the time it's come out, I will tell you it's probably best to install CUDA versions 11.8 and 12.1 or 12.4. But if you want to know the reason why, then here is the reasoning behind this decision. When you research AI tools that you want to install, you need to make note of at least 3 things, which is number 1, which Python version each AI tool depends on, 2, which Pytorch version each tool requires, and 3, which CUDA toolkit versions are compatible with those Pytorch versions. So why do we care about something called Pytorch? Pytorch is an open source machine learning resource used in many AI tools. Your CUDA version must be compatible with your Pytorch version for these programs to work. And why do we need to know about our Python versions? That will be necessary when creating our virtual environments, which will be discussed in the next video. Now, to determine required Python and Pytorch versions, this can take a bit of effort. First, you want to check the GitHub sites and repositories of each AI tool. And remember, a repository is basically a storage location containing all the project files and resources, including those needed to run the software. You will want to look for words like PyTorch or Torch and Python. And if you're lucky, the AI tool's main GitHub page clarifies version requirements. For example, AudioCraft very clearly tells us on its main GitHub page under installation instructions that it needs Python version 3.9 and PyTorch version 2.1.0. Now that's all very nice and clear, but more often than not, you will have to dig around for version info. So here's another example, RVC voice conversion. First of all, it's in Chinese, so you have to right-click and translate to English. It does not specify PyTorch or Python versions clearly in the installation instructions. So let's check something called requirements.txt. It will be a file within the repository. Nope, Torch is not listed there either. And neither is the Python version. Next, let's take a look at another kind of file in the repository, the .toml file. Under dependencies, we can see Python version 3.9 and Torch version 2.4.0. Now, the caret in front of Python version 3.9 means you can use any version of Python 3. Basically, the version number has to match the leftmost non-zero digit, which is number 3. This means that you can use the most recent version of Python 3, but not, for example, Python 4. And of course, this is a hypothetical example since Python 4 does not yet exist. Now let's say you still can't find anything about, for example, PyTorch in the .toml file. Then you have to look at the poetry.lock file and search for Torch. This file is a lot more detailed, so hit Ctrl F or Find to search for the word Torch. There are other files that you might check in case you don't have a poetry.lock file or a .toml file, because not all projects will use those files, but you might have something called a requirements.yaml or environment.yaml file. For example, here's an AI tool called Mimic Motion. We look under dependencies and find that Mimic Motion depends on Python version 3.11 and PyTorch version 2.0.1. It also seems to prefer CUDA 11.7. You can also try clicking Insights and Dependency Graph and search for the dependency that you're looking for. And we find that this project requires Torch 2.1.0. Now, sometimes you can't easily find the required Python or Pytorch version for an AI tool. And it's not always that straightforward because that info might not even be on the AI tool's GitHub page. It could be buried in its dependencies. So to describe this concept, let's make an analogy. You can think of your AI tool as a penthouse of an apartment building. The penthouse depends on the floors below to stay stable, just like your AI tool depends on other open source tools. In other words, its dependencies to work. And each floor in this building is like a dependency. And each of these dependencies have their own GitHub repository, like its own apartment. And let's say you're dealing with a plumbing issue, something like a compatibility issue with Python or Pytorch. You start by looking at the maintenance guide in the penthouse, or analogously, the AI tool's GitHub page, but you can't find the info on that page. So to fix the issue, you have to check what's happening on the other floors. Sometimes you'll find clues to solve your problems only by exploring these lower levels. In short, version info can be hidden in these dependencies because the tool that you're using, in other words, the penthouse, assumes you already understand or have configured the floors below, in other words, its dependencies. And that's why you might have to search not only the AI tool's GitHub page, but also the GitHub pages of its dependencies, and sometimes even the dependencies of those dependencies. And that's why it gets pretty gnarly trying to figure everything out as a beginner. But in most cases, you should be able to find the Python or Pytorch versions, especially with more popular open source AI tools. Now let's head on to step 6, which is to choose your CUDA version or versions based on Pytorch compatibility. So let's take a look at the Pytorch website. And again, the link is in the description. One thing that you notice is the most recent version of CUDA, which is 12.6, is not compatible with Pytorch, at least at the time of this video. This means that you should not install the most recent version of CUDA, since 12.6 is incompatible with Pytorch, which means that the AI tools we've just researched will not run. Now let's look at previous versions of Pytorch. Since we had just looked at an AI tool called AudioCraft and saw that it required Pytorch 2.1.0, let's search for that version on the Pytorch website. You want to look for Linux and Windows and the command pip install. And we can see that only CUDA 12.1 and 11.8 are compatible with Pytorch 2.1.0, which means that to run AudioCraft, which requires and depends on Pytorch 2.1.0, you must have CUDA 12.1 or 11.8. With the AI tool called RVC Voice Conversion, it requires Pytorch version 2.4.0. And we find that Torch 2.4.0 is compatible with CUDA 11.8, 12.1, and 12.4. For now, I only need CUDA 12.1 or CUDA 11.8, but I will install both versions, and you will see how to have multiple CUDA versions on the same system. However, even if you do have multiple versions of CUDA on one system, you can only use one default CUDA version at a time. And I will show you a little bit later how to switch CUDA versions when I discuss environment variables. Moving on to step 7, which is to check your Nvidia driver compatibility with CUDA. Before installing CUDA, we have to ensure that our Nvidia driver version can support the CUDA version that we want to install. In this case, CUDA 11.8 and 12.1. So let's go to the address bar of File Explorer and type in cmd. This will open an application called Command Prompt. And this is an application where you can type commands. Note that cmd is a common shortcut to open Command Prompt. You can also open Command Prompt using the search bar at the bottom of the screen. And once you're in Command Prompt, you can type NVIDIA-SMI to see NVIDIA driver info. You can find the driver version here as well. It says 560.94. On the right, it shows CUDA version 12.6. This actually does not mean that we have CUDA 12.6 installed. Instead, this informs us of the highest possible CUDA version currently supported by our GPU driver. So we can install CUDA version 12.6 or lower. So this verifies that it's fine for us to proceed to install CUDA 12.1 or 11.8 since they are lower than 12.6. Now, if on the other hand, you had an older GPU driver, let's say driver version 526, then only CUDA 11 versions would be compatible with it. And you would have to update your driver so that it could support CUDA 12. We can see this also in the Nvidia documentation where the minimum driver version for CUDA 12 is 527.41. Next, let's double check that CUDA is not already installed. Again, we want to open Command Prompt, whether that's typing in CMD in the address bar of File Explorer or in the search bar at the Start menu and opening Command Prompt from there. Once you're in Command Prompt, you want to check CUDA by typing nvcc-version. And here you can see that I already have CUDA 12.1 installed. If you don't have it installed, it will say that it is not found and you will have to install it. Next is step 8, which is to install Visual Studio for C++. And that's because before we install CUDA, we must have a C++ compiler like Visual Studio. Otherwise, CUDA's installation process will not work. So you want to visit the Visual Studio downloads page and start scrolling down. Under Tools, you want to select Build Tools for Visual Studio 2022. You can click here to find previous versions. And for CUDA compatibility, I would suggest downloading version 17.8 since it seems like newer versions like 17.10 has caused issues for folks who are using CUDA 11.8 and 12.1. In the Downloads folder, you want to find your downloaded file and right-click. Then select Run as Administrator and press Continue. During installation, you should select the Workloads tab and check Desktop Development with C++. And if you see the menu on the right, you can click Select All, including Windows SDKs. Hit Install. Once that's done, you want to close out all Visual Studio windows in case you have any open, and you want to restart your computer. All right, this is step 9, and we are ready to install CUDA. And for that, we go to Nvidia's CUDA page. You will select the CUDA version or versions most compatible with your Pytorch versions that are necessary for your AI tools. Then you select the installer for your operating system, in this case Windows 11. It can take a while to download, so you can proceed to the next step, which is downloading and installing ffmpeg while you wait for CUDA to download. Once CUDA has downloaded, you can double-click, open it, and click OK. I'm not going to go through all the steps to install CUDA 12.1 since I already have it installed, but let me show you the installation process for another version of CUDA, which is version 11.8. Let's go with custom installation option since I do not want to overwrite my driver. And you can go with custom installation 2 for whichever version of CUDA you have chosen. You want to check all boxes like CUDA, other components, and driver components. If the installation looks slightly different from my screen, let's say you have something called Nvidia GeForce Experience as an option, that's not necessary for installing CUDA, so you can uncheck that box. In my case, a notification popped up since I already have Nsight installed, and it's just telling me that it will not downgrade that version of Nsight. Once everything is installed, you can restart your computer. Lastly, let's verify that we have CUDA installed by opening Command Prompt and typing nvcc-version. This will tell us the default version of CUDA. In this case, I have CUDA 12.1 as default. but I will show you how to switch to CUDA version 11.8 when discussing environment variables. Step 10 is installing ffmpeg. ffmpeg is critical for processing audio and video files in many AI tools. We can go to ffmpeg builds and download the latest version. Once it's downloaded, right-click ffmpeg and show more options, extract with 7-zip. You will want to rename the extracted folder to ffmpeg, then move that extracted folder to your C drive. The ffmpeg folder content should look like this. We are now ready for step 11, which is to set paths for our environment variables. First, what does that mean? By setting paths for environment variables, this will inform Windows where to search when you issue a command that relies on some of the software we just installed. For example, when we create virtual environments or use Python, we will be relying on Miniconda. And to do that, it's convenient to type our conda create command in command prompt. Without creating a path to Miniconda though, Windows will not know how to execute that command. But by creating a path to our Miniconda directory, then we can utilize Miniconda functions directly in command prompt. Additionally, this is where we can switch between our default versions of CUDA. So if we want to change our default CUDA from 12.1, which it currently is, to 11.8, we can do so by changing the order of our environment variables. Your computer prioritizes environment variables from top to bottom. So if you have multiple CUDA versions, list your default CUDA version at the top. So how do we edit the system environment variables? We can search by the Start menu, start typing environment. Click Edit the System Environment Variables. Click Environment Variables. You can either edit paths under User Variables, that's the top half of the window. As you can see, I don't really have my paths set up here. Mine are actually in System Variables, which is the lower half of the window, and I'm editing System Variables since my software has been set up to function system-wide for all users, not just one user. You can see my paths here. The first two are for CUDA 12.1, and next are those for CUDA 11.8. But since 12.1 is on the top, that's going to be the default version. Now let's say you wanted to change your default CUDA to version 11.8. You would have to move up these CUDA 11.8 paths so that CUDA 11.8 is at the top. You also have to edit CUDA underscore path to change the default to 11.8. Make sure you press OK to save all changes. And once you've closed out of those windows, you can open Command Prompt, type in nvcc-version, and you can see the default version of CUDA has now changed to version 11.8. I'm going to switch my default CUDA back to 12.1 and repeat this step so you can see how switching between CUDA versions is done again. Change CUDA underscore path to CUDA 12.1. Go to Path, click Edit, switch the order of the paths so CUDA 12.1 are above CUDA 11.8. Now my default should be back to CUDA 12.1, but just to confirm, we should open Command Prompt and type nvcc-version. And now you can see that it has changed back to CUDA 12.1 and 11.8 is no longer default. We also want to make sure paths are set up for ffmpeg, git, and as mentioned before, I also like to add Miniconda to the path so I can access conda commands from command prompt. If you don't see these paths, then you have to create them. Press New, and you can either press Browse to find the directory that you're looking for, in this case ffmpeg, or you can simply type in the path. So why again do you need to set up environment variables? This is to ensure that you can run CUDA, Git, ffmpeg, and in my case, Miniconda tools in command prompt. So we are finally arriving at the final step, which is to verify your setup and to confirm that everything is installed correctly. Now we will be opening command prompt and typing in the following commands one by one. And each command will verify whether a certain software is installed, and if so, which version. So let's start with Git. We'll type in git -- version, and it should tell you whether Git is installed and which version it is. Next, conda -- version, ffmpeg -- version, nvcc -- version, that's for your CUDA driver, and lastly, Python -- version. Now, if you set up your computer exactly as I have in this video, including the same environment variable paths, including the path that's set up with Miniconda, then each of these commands should receive a response. And if you have anything that's not found, then you should double check that your software is installed with the correct environment variable paths set up as shown in this video. And as everything checks out, then we are ready to start experimenting with virtual environments. Now here's an optional step, which is how to uninstall programs on Windows. And this is only if you experience issues or need to uninstall programs or older versions of programs because it tells you to. So only really do this if it's necessary, because sometimes uninstalling software could have some unintended consequences. For example, if you were to uninstall Miniconda in the future and you have projects that you were working on and they were set up in Conda virtual environments, when you uninstall Miniconda, it will automatically delete those Conda virtual environments and you might find your whole setup is missing. So do be careful and do some research before you go uninstalling things. But I can tell you that you can safely uninstall programs like 7-zip, ffmpeg, and Git. So how do you uninstall a program on Windows? You go to search bar at the bottom of the screen, type in add, select add or remove programs, find the program you want to uninstall, click 3 dots to the right of the program and hit uninstall. All right, so you've done it. You've globally installed necessary software for your very own AI workstation. Until next time.